All right, while you're digging that out, let's talk about after Thanksgiving. When you guys come back from Thanksgiving, we're changing the schedule a little bit on Mondays. I don't know if you've heard about this yet or not, but Mondays, when you come back from Thanksgiving, instead of, you'll still alternate every other Wednesday, but we're gonna do all 8 periods on Mondays. And basically in geometry, what we're gonna use those periods for, it's gonna be a 40-minute class. We're gonna use that time for test retakes, quiz retakes, turning in things you're missing, if you're falling behind on stuff. If you haven't taken a test or quiz yet, we'll do those things during that Monday on that short period. So in order to do those things, like to retake a test or a quiz, remember you gotta have all your homework turned in, you gotta do the retake assignment, all of those things. So if you plan on retaking a test or quiz on one of those Mondays, you have to have all those things done previously before you come in to retake it on that Monday. So just keep that in mind. The first Monday after Thanksgiving, if that's the day you guys come in and there's a quiz or a test you want to retake, just make sure you've got all the homework done ahead of time. Make sure you got the test retake or the quiz retake done ahead of time. And then as soon as you come in on that Monday, we can give you the quiz or the test to retake. All right. If you're all caught up, you've got everything where you want it, then basically that day would just be used as basically a study hall. Any questions with that Monday when we come back from Thanksgiving? Okay, and that'll probably last through the rest of the semester, maybe the entire year, depending on how things go. Okay, that's our plan after Thanksgiving. On your quiz review, this 4.2 to 4.5 quiz review, when we get to tests and quizzes, we will always tell you on a test or quiz how many steps there are to each proof. So if you go to the bottom of that first page, we didn't tell you how many steps they would be. So we're going to do that here. So number 13, just write it next to it somewhere. Number 13 takes you 3 steps to prove that one. Then if you go to 14, takes 4 steps. Fifteen takes you 6 steps. And I'll move it up as we go here. Let's see, 16 takes you 3 steps. And 17 is 4 steps. All right, so one more time real quick, in case you tuned in late. 13 was 3 steps. 14 was 4 steps. 15 was 6 steps. 16 was 3 steps. 17 was 4 steps. And again, your answer keys for these are going to be on Google Classroom. So as you're doing this, you can check to see what those steps are and if you got them correct. Okay. All right, next, your notes. We're going to kind of do your notes part in your notebook and part out of the packet. So wherever you're going to keep your notes, take those out. And we'll get today's date in there. Today's Monday the 9th. And we're covering 2 different sections today, 4.4 and 4.5. we got 4 proofs we're going to do here in your notes, and then we're going to go to the packet and do some proofs in there also. And then the rest of the time will be yours to kind of work on those things. All right, first one we're going to do, and let's start with the picture here. We have a 4-sided figure, a diagonal going through it. And we want to start getting in the habit of kind of looking at your picture and noticing certain things in the picture, because it'll make your proofs a lot easier if you notice some of these things. So when you look at this picture, what we want you to notice is these 2 triangles, the triangle on top, the triangle on the bottom, share side TR. If you remember back to last week, if they share side TR, we can say that TR is congruent to itself by the reflexive property. So that's one thing we always want to look for in our pictures. And then we're going to be given a couple of things here. I'm going to abbreviate given with a capital G. We're going to be given that QR is congruent to SR. And ST is congruent to QT. And then I'm going to abbreviate prove with a capital P. We're going to prove the 2 triangles are congruent. Triangle QRT and triangle SRT. And this one's a short proof. I think it's just 3 steps to get us through this. Abbreviate statements on the S with an S on the left, reasons with an R on the right. And then we'll start it off. First step, no matter how difficult the proof is, you should be able to get your first step. First step's always the given rather than rewriting all that. I'm just going to do this. First step is given. And then what you're going to want to do with your proofs, especially on these triangle proofs, you're going to want to make sure you put the given into your picture. So over here on the given, QR is congruent to SR. That's the top and the right-hand sides. Those 2 are congruent. And then ST and QT are congruent. ST is on the bottom, QT is on the left. And then our second step we already talked about. These 2 triangles share TR. So I can say that TR is congruent to TR. TR is congruent to itself by the reflexive property. And to show that in our picture, I'm just going to take TR and put 3 marks through it. And we're trying to prove these triangles are congruent. The other day, we gave you 5 different ways to prove triangles were congruent. We had side, 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 angle, side, angle, side, angle, 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 side. And then the long way is the definition of congruent triangles, which we don't use a whole lot on these proofs. But those are our options. Now, when you look at these 2 triangles, we have all 3 sets of sides congruent to each other on the 2 triangles. These 2 are marked with 1, these 2 are marked with 2, and they share that side marked with 3. So now in our third step, we can say the triangles are congruent. Triangle QRT is congruent to triangle SRT. Which 3-letter shortcut we using here? Yep.
SSS.
This one's SSS. You get all 3 sets of sides. Now, the more of these you see, the more you're going to start to notice these patterns, which will make things a little easier for you. Here is our next proof. I'm going to go back here and call this one number 1, just so we can identify when we're starting a new one. Here's number 2, our second proof. Second proof, the picture, we'll start with that. And again, as soon as you look at the picture, one of the things we want to look for, first of all, is a shared side, because we can use reflexive property on that. The other thing you want to look for is vertical angles. And on this picture here, we've got vertical angles right here. Okay, again, anytime you see vertical angles in your picture, you're almost always going to use that in the proof. So we'll keep that in the back of our mind because we're going to use that here later on. All right, with this one, we're going to have two parts to the given. Again, it's going to tell us R is the midpoint of two different things. It's going to be the midpoint of QS and PT. And then we're going to prove the two triangles are congruent to each other. And again, it's not a real long proof, so you don't have to take up too much space in your paper there. Now, again, we want to prove the two triangles are congruent to each other. We've got our three-letter shortcuts to do that. SSS, SAS, ASA, AAS. We're going to try to use one of those to come up with these two triangles being congruent to each other. So first step, again, is the given. Bring that down here. And then before I can mark my picture, I need to know what they're telling me in the given. So we're going to describe what the given is telling us in step 2. In your given, you'll notice we have one of our vocabulary words, midpoint. When a vocabulary word shows up in your given, we almost always use the definition of that in our proof. Here they're telling us R is the midpoint of QS and PT. Let's just start with the first part. R is the midpoint of QS. Here is R. They're telling us it's the midpoint of QS, which means it's right in the middle of QS. So if R is right in the middle of QS, that's going to split that segment in half. QR and RS are going to be congruent to each other. So that's what we're going to put for step 2. QR is congruent to RS. And then we're going to have a second part to that step 2. R is also the midpoint of PT. So point R is going to be right in the middle of PT. That's going to split PT in half also. So PR is going to be congruent to RT. And the reason we could say both of those things is the definition of a midpoint. They told us in the given that it was a midpoint. The definition of a midpoint tells us it splits the segment into 2 equal parts. So now if you look at your triangle, you've got 2 sets of corresponding sides that are congruent to each other. If we can get one more set of corresponding parts, we've got it made. And we already talked about this before. We've got vertical angles here. As soon as you see vertical angles, you know they're automatically congruent to each other. So let's mark those 2. And then we'll put it in our proof here. This triangle on the left, or this angle on the left, is PRQ. It's going to be congruent to the angle on the right, TRS. The reason those are congruent is the vertical angles there. Since they're vertical angles, they will be congruent. And that gives us our third set of corresponding parts that are congruent to each other. So now we've got enough, since we have 3 sets of corresponding parts congruent. We can say these 2 triangles are congruent, PRQ and TRS. And then we just got to figure out which one of our 3-letter shortcuts it is. Anybody think they know this one? What do you think? SAS. This one is SAS. The angle is in between the 2 sets of congruent sides. That's side angle side. All right, now keep those first 2 in mind as we keep going through here. Two things you always want to look for in your pictures: if they share a side and vertical angles. Now we're going to take it one step further. I'll call this number 3. This time our picture we got a triangle on top and a triangle on the bottom. And then again, what we want you to see as soon as you look at the picture, these two triangles share side JL. Top triangle and the bottom triangle share side JL. So we're going to use that reflexive property in our proof. And usually it's the third proof where people kind of start to understand how these things work here. All right, we'll start with our given. Our given is, let's see here, angle K is congruent to angle M. JK is congruent to JM. Yeah. And one other part, JL is going to bisect angle KLM. And now our proof, this time we're going to go take it one step further. Instead of proving that the two triangles are congruent, now we're going to prove that some corresponding parts are congruent. We're going to prove that KL is congruent to ML. And really all this is going to do is going to add one step to our proof. Let's take care of this one. Once again, same plan. We want to get the two triangles congruent by one of our 3-letter shortcuts. And then we'll add on the one extra step on there. So first step again, going to be the given. We've got a bunch to our given here. This is all going to come down for the first step. And then just like before, we want to mark our picture. Angle K is congruent to angle M. That's these top angles, the top and bottom angles. JK is congruent to JM, so that's this one and this one. And then the last part of our given has a definition in there, bisect. That's one of our vocabulary words. So we're going to have to describe what's happening with the bisector part. It says JL bisects angle KLM. And if you remember back to chapter 2, when something bisects, that means it's going to cut it in half. So JL is going to go right through the middle of angle KLM. Well, here's JL. Where it hits angle KLM, it's going to split it in half. So that's going to make these two angles congruent to each other. And that's what we're going to put in here as step 2. So angle KLJ will be congruent to angle MLJ. And can anybody figure out a reason on step 2? It's coming from our given where they tell us it's a bisector. Any ideas? Go back to our last one. We had midpoint, one of our vocabulary words in the given. We use definition of midpoint. Same thing here. We've got bisects. It's going to be the definition of a bisector. So when you have a vocabulary word show up in that given, we're going to use the definition of that in our proof. And now if you look at your two triangles, we have 3 sets of corresponding parts that are congruent. These two angles are congruent, these two angles are congruent, and these two sides are congruent. So I have enough now to say the two triangles are congruent. Triangle on top would be triangle JKL. Triangle on the bottom would be JML. Which of our 3-letter shortcuts is this one? We have 2 sets of angles congruent and the side that's not in between them. Yep. This one's AAS. We have the non-included side, it's not between the 2 angles, so it's angle, angle, side. Now, typically that's where we would finish our proof, but now they want us to go one step further and say that KL is congruent to ML. Now, if you remember back to last time you came to class, when the triangles are congruent, we know all of their corresponding parts are congruent. And we use that 5-letter shortcut to abbreviate that, CPCTC. Corresponding parts of congruent triangles are congruent to each other. So once I get the 2 triangles congruent, then all of their corresponding parts would be congruent. If you look at KL and ML, those 2 would be corresponding parts. So now in step 4, I can say KL is congruent to ML. My reason is CPCTC. So you're going to start to see a lot more proofs where that CPCTC becomes your last step. That's when you're proving that corresponding parts are congruent. But it's the same game plan. Get the triangles congruent to each other first, then you can go to CPCTC to finish it. All right, let's write out one more. Usually on our 3rd or 4th one, that's when people start to kind of get the hang of these. Here's going to be our picture. And hopefully as soon as we draw that picture, you notice the 2 triangles share a side, side FH, so we're probably going to be using that reflexive property in our proof. This time our given is going to have 2 parts to it. GH is going to be parallel to FJ. And angles G and J, measure of angle G and the measure of angle J are going to equal 90. And again, on this one, instead of proving the triangles are congruent, we're going to go one more step. We're going to prove that corresponding parts are congruent to each other. And I think this one's going to take us 4 or 5 steps to get through. All right, first step. We know the first step is going to be the given. So I'm just going to bring this down here instead of rewriting all of it. That's going to be given to us. And then you want to mark your picture with that given. GH is parallel to FJ. That's the top and the bottom. Those 2 are going to be parallel. And then the other thing they tell us is angles G and J are 90 degrees. So to show that those are 90-degree angles, I'm going to put the little box in the corner of both of those. All right, for step 2, now this is something when you guys look at the picture, you probably notice those 2 right angle boxes and immediately think those are congruent to each other. Now, when we have a proof, especially on Alex, Alex just doesn't assume those are congruent because their boxes are, in Alex, they actually make you go ahead and say that those 2 angles are congruent to each other. So we have to say that angle G is congruent to angle J because they're both right angles. And we have a theorem that says all right angles are congruent. If you remember back to chapter 2 when we did that yellow cheat sheet, that was on there, all right angles are congruent. So if we put the little box in the corner, we have to put in our proof that they're congruent to each other by all right angles are congruent. So that gives us one set of angles. We already said the 2 triangles share FH, so let's get that in here before we forget. FH is congruent to itself by the reflexive property. And then I'm going to mark that in my picture also. FH is congruent to itself, so I'm going to mark that as congruent to itself. And then for our last set of parts, right now we've got two sets of corresponding parts congruent to each other. We've got a set of angles, we've got a set of sides here. We need one more set of parts that are congruent to each other. And to get this one, we have to go back to our given. They tell us that two lines are parallel to each other. So now another thing you want to look for in these triangle proofs, anytime you have parallel lines like this, you want to look for alternate interior angles. Because if the lines are parallel, your alternate interior angles are congruent. So if I take these two parallel lines, my two alternate interior angles would be this one and this one. And then we got to put that in our proof. That's angle GHF and angle JFH. Those two are going to be congruent to each other because the lines were parallel. So alternate interior angles are congruent. That's the alternate interior angles there. So there's another thing now to look for in all of these triangle proofs. If you have parallel lines, look for those alternate interior angles. And now that gives us our three sets of corresponding parts. We've got a set of angles here. We've got a set of angles here. We've got the set of sides right there. So I can now say the triangles are congruent. Triangle, let's go the same letters here. Triangle GHF is congruent to triangle JFH. On this one, we have our two sets of angles, and we have the set of sides. The side is not in between the two angles. So this one's going to be angle, angle side. And in a lot of our proofs, that would be enough. We'd be finished. But we want to go one step further. We want to say that GF is congruent to JH. Since the two triangles are congruent, now we'd say that GF and JH, these two corresponding parts, would be congruent. And the reason those are congruent is CPCTC. Since the triangles are congruent, the corresponding parts are congruent. All right, now, like I said, after 3 or 4 of these, sometimes that's when people start to kind of get the hang of it. How many think they're starting to get the hang of the triangle proofs? Okay, we'll get there. We're going to do some more. Now, the rest of these, we don't have to draw the pictures in. If you go to your packet, in your packet, we should have a proof packet. Looks like this. And we're going to start this together, and then we're going to have you finish it off yourself. Well, we've got plenty of time today. We're going to do about half of these together. I just have to remember which ones they are. We're going to start, well, let's start here at the top. Wants to know what theorems, postulates, or definitions do you use to prove triangles are congruent to each other? We have our 4 3-letter shortcuts that will prove triangles are congruent to each other. What's one of them? AAS works. What's another? SAA. Oh, that's AAS backwards. Yep. So that's the same thing. Yep. What's another one? SSS works. There's 2 more. SAS. Which one are we missing? There's a 4th one. What is it? ASA. There you go. There's our 4 3-letter shortcuts. And then the other way to do it is the long way, the definition of congruent triangles. We don't do a whole lot of proofs where we use the definition of congruent triangles. Definition of congruent triangles is where you have to show all 6 sets of parts are congruent. You show that you have 3 sets of congruent angles and 3 sets of congruent sides. These 3-letter shortcuts make this a lot easier, so we usually end up going with those. All right, the next question, when do you use CPCTC in a proof? We're going to use CPCTC when we're proving corresponding parts are congruent. And the y part of this, I'm not going to write out the y part of it. You can add this on your own here. They want to know why we use CPCTC. Well, once you get two triangles congruent to each other, then all of their corresponding parts are congruent to each other. So we're going to use that CPCTC once we have the triangles congruent, because that proves that your corresponding parts are congruent. All right, we're going to bounce around a little bit here on the packet here. We're going to start with number 2. So here we got number 2 down at the bottom. And we got the picture drawn for you. Basically, all we have to do is fill in the statements and the reasons. This is what it's going to look like when you get to your next test or quiz. The next time you come to class, we're going to have that quiz 4.2 to 4.5. So it's going to look like this. We're going to tell you how many steps there are. We give you the picture, we give you the given and the proof. You have to fill in all the statements and the reasons. Now, before I even do this proof, let's look at the picture. Hopefully something jumps out at you in the picture. What's something you should notice in your picture? We've got vertical angles, so that's one thing we're going to use in our proof. If you look at the proof statement, we're proving the triangles are congruent to each other. So we're going to use, probably going to use one of these 3-letter shortcuts. Otherwise, we'd have to use the definition of congruent triangles. It's only a 3-step proof, so it's going to have to be one of those 3-letter shortcuts. All right, let's start it off. Once again, I don't feel like rewriting all that given, so I'm just going to do a little arrow down here. And our given, we're going to mark that in our picture. Angle LOM is down here. They've already marked it there. It's congruent to NPM, which is marked right there. And the two sides, LM and NN, they've marked those for us. So after the given, and I got to put that in our reason for step 1. After the given, we've already got 2 sets of corresponding parts that are congruent to each other. We just need to get a third one. And Kaya told us we have vertical angles here, so we're going to put those in. For step 2, your vertical angles are LMO and NMP. And we know those 2 are congruent because they're vertical angles. That's the vertical angles there. And then if you look at your picture, now you've got 3 sets of corresponding parts that are congruent. You've got a set of angles here, a set of angles here, and a set of sides there. So we can now say the 2 triangles are congruent. We just have to figure out which of our 3-letter shortcuts it is. So we've got our 2 sets of angles. We've got the set of sides. The set of sides is not in between the 2 angles. So if you go back to your 3-letter shortcuts, which of those 3 do we have, or which of those 4 do we have here? I'll go back to our picture. AAS. You got your 2 sets of angles. The side is not in between them, so it's AAS. All right, that's a good one to start with. Get us rolling here. Let's go to number 3. On number 3, we're going to prove the triangles are congruent to each other again. Just 3 steps to get there. As soon as you look at your picture, what should hopefully pop out at you in the picture? They share a side right here. GF is shared by both triangles. So we're going to use that reflexive property, say GF is congruent to itself. But first, we got to do the first step. This is given. And they've already marked the picture. They marked the given for us in our picture. Angles E and H are congruent. And angle HGF up here is, or HFG is congruent to EGF. Those 2 are congruent to each other. And then we said they share a side here, so let's get that in step 2. GF is going to be congruent to itself, so I'm going to mark that with 1 mark there. GF is congruent to GF by the reflexive property. And then if you look at your picture, you've got 2 sets of angles congruent to each other. You've got a set of sides congruent to each other. So we can now say the triangles are congruent. Triangle EGF is congruent to triangle HFG. And once again, we just have to figure out which of our 3-letter shortcuts it is. Sometimes it's helpful to cover up one of the triangles. Here's your 2 angles. The side is not in between them. Which 3-letter shortcut is that? AAS again. All right, how many, if they saw this on a quiz next week, how many think they could handle it? Okay, we're starting to get there. Okay, let's go to number 6. Number 6. Number 6, we're given 4 different things here. Angle 1 is congruent to angle 2, AB and BL are perpendicular, KL and BL are perpendicular, and AB is congruent to KL. That's all going to go in as the first step are given. And then I probably should have started with this. When you look at the picture, we know there's things you always want to look for in your picture. If we have vertical angles, we want to use that. We don't have vertical angles in our picture. If you have a shared side, we want to use that, but we don't have a shared side. That third one just came up a little bit ago. If 2 sides are parallel, we want to look for alternate interior angles. We don't have parallel lines in here, so we don't have to worry about those. So this one, we're going to kind of be on our own. Now, they've marked angle 1 congruent to angle 2 for us. These 2 in the middle, I'm going to come back to. Let's get AB congruent to KL. Here's AB on the left. Here's KL on the right. Those 2 are congruent also. And then the middle parts, I just have to know what this symbol means. That upside down capital T means perpendicular. Perpendicular means they're going to form right angles. So where AB and BL meet, we're going to get a right angle. Here's AB and BL. They're going to form a right angle. And over here, KL and BL are going to form a right angle. Now, once again, just like we did before, we have to put that into our proof. Those 2, actually, I got to put that they're right angles because they give us perpendicular here. So we have to say that angle ABG and angle KLG are right angles. And the reason I got to do that, they did the symbol here. Typically, they would write the word perpendicular out here. When you have the word in your, the vocabulary word in your given, we're going to use the definition of that down here. The definition of perpendicular says you get right angles. So that's where this is coming from. And if you want to write out perpendicular, you can, or you can use the symbol for perpendicular. But the definition of perpendicular gave us right angles here. And then we'll go back to that step I said before. When we look at these 2 boxes, we immediately think those are right angles that are congruent to each other. But if this was an Alex proof, you got to say that those are congruent to each other. So we have to say that angle B is congruent to angle L because all right angles are congruent. And then we made it. Now we've got 2 sets of congruent angles. Those 2 there, the 2 right angles, and then we got a set of congruent sides. So we can say the 2 triangles are congruent. And it's just a matter of us figuring out which of our 3-letter shortcuts we have here. If it helps, you can cover up the picture. Anybody figure out which of our 3-letter shortcuts we have here? It's AAS again. Yep. Now, I don't want you to think it's always going to be AAS. These first 3 just happen to be AAS. We'll probably see them all happen about an equivalent amount of times, each of those 4 3-letter shortcuts. All right, let's go to the next one. Let's go to number 8. All right, number 8, we got a 5-step proof to this. Now, before I even start it, I'm going to look at the picture. I have parallel lines. When we have parallel lines, what's one thing we should look for?
What?
If we have parallel lines, what's something we should look for? Alternate interior angles. In fact, we've got 2 sets of alternate interior angles here. Angle R and U would be alternate interior, and angle Q and T would be alternate interior. Okay, so we'll go use those here in a little bit. Now let's start with the given. Put the given down here, and then we'll mark our picture. All right, it says S is the midpoint of QT. I'm going to come back to that in just a second because that's one of our vocabulary words. The QR is parallel to UT. We've got that marked over here. Now let's figure out what S is the midpoint of QT is telling us. S is the midpoint of QT. That means S is right in the middle of QT. If S is right in the middle of QT, what 2 things would be congruent? Yep.
QS and ST.
QS and ST. S is right in the middle of QT. It's going to split QT in half. So QS and ST are going to be congruent. That's going to be our next step. QS is congruent to ST. And like we said before, if the vocabulary word shows up in your given, we're going to use the definition of that down here in the proof. So definition of midpoint down here. Okay, so now we've got 1 set of congruent sides. And then as I look at this one, there's more than one way to do this proof here. Another thing we could look at is we've got vertical angles. So we said anytime vertical angles show up, let's go ahead and put them in. Let's do that. We would have angle RSQ and angle UST. So now we've got a set of angles congruent to each other. We've got a set of sides congruent to each other. And then my 4th step, I could go one of 2 directions here. We have parallel lines. So anytime we have parallel lines, we're going to look for alternate interior angles. So we could go with angles R and U or Q and T. It doesn't matter which ones we go with. I'm going to go with, just to mix it up, let's go with Q and T. And the reason Q and T would be congruent to each other is because you have parallel lines and they're alternate interior angles. So this is the alternate interior angles theorem. And now we got it made. We've got our 3 sets of corresponding parts congruent to each other. So I can say the triangles are congruent. QSR is congruent to TSU. We just have to figure out which 3-letter shortcut we have on this one. And again, it might be helpful to cover up one of the triangles. You've got 2 sets of congruent angles. You've got the set of sides that's in between those 2 congruent angles.
ASA.
That one is ASA. Now, I was telling you this proof could have been done 2 different ways. If instead of picking angles Q and T, if you picked R and U in step 4, you still would have had alternate interior angles theorem. But now, instead of ASA, you would have had angle side. So sometimes these proofs can be done more than one way. These last 2 steps could have been done differently. All right, how many think they're starting to get the hang of the proofs now? Okay, getting more of you. Let's keep going. Let's go to number 10. Number 10, once again, if you look at your picture, first thing hopefully you notice is they share a side, CB. So we're going to use that reflexive property in our proof. Let's start with the given. First step is the given. So we'll bring that down here. And once again, the given has a vocabulary word in it, bisects. So when you see the vocabulary word in the given, we're going to use the definition of that down here in our proof. And let's start with the first part. CB is going to bisect angle ABD. So where CB comes up and hits angle ABD, it splits it in half. So let's put that in our proof. That's angles ABC and BBC. And then I'm going to squeeze these two into the same step here. It's also going to do the same thing to angle ACD. CB is going to bisect angle ACD. So here's ACD on the bottom. It's going to get split in half. That's going to make angle ACB congruent to angle BCB. Now, I didn't look ahead when I did this. It's possible they may have wanted us to do that in two different steps. But since they're both going to have the same reason, I'm going to do it in the same step here. So those two, we know those are congruent by the word bisector being in the given. That's going to be a definition of bisector. When you see the vocabulary word in your given, we're going to use the definition of that in your proof. Okay, that gets us two sets of congruent angles. We said as soon as we looked at the picture, we noticed CB was congruent to itself, so we're going to mark that by the reflexive property. And now I've got three sets of congruent parts. I've got two sets of congruent angles. I've got the side in between them. That's going to allow me to say the triangles are congruent. Call the first one triangle ACB. Call the second one DCB. There's three different ways you could write that congruent statement either way. Either of those, any of those three is going to be fine. Now we need to know which three-letter shortcut we have here. Which of the three-letter shortcuts do we have in the picture? This one is ASA. The side is in between two angles. And then we do have one more step to it. We proved the triangles are congruent to each other. They want us to prove that the corresponding parts are congruent to each other. So once I get these two triangles congruent to each other, then I can say the top and the right-hand side are congruent to each other by CPCTC. So AB is congruent to BB. All right, one more together. Number 12. Number 12, in your picture, hopefully you see a couple things. You've got parallel lines here. So we're going to look for alternate interior angles with that. We've got a shared side. QT is shared by both, so we're going to use reflexive property there. Now, we just did one where we ended up proving corresponding parts were congruent to each other. We ended in CPCTC. On number 12, we're going to prove that two angles are congruent to each other. If I'm proving two angles are congruent to each other, am I going to end with a three-letter shortcut or with CPCTC? We want to prove angles are congruent to each other. Not proving triangles, we're proving angles. This one's going to end in CPCTC. So I'm going to go ahead and put that down here on the bottom, just so I don't forget that. Same thing's going to happen here in number 11. We're going to prove that PQ is congruent to TS. We're not proving triangles are congruent to each other. We're proving corresponding parts are congruent. You're going to finish with CPCTC on that one also. Okay, back to 12. We're going to start with our given. And they've marked both parts of the given in our picture for us. So we got the parallel parts marked, and angles R and S are congruent to each other. So at this point in our proof, we have one set of corresponding angles that are congruent. We need to get two more sets of parts. So let's start with the parallel part here. Since the lines are parallel, our alternate interior angles are going to be congruent. That would make this alternate interior angle congruent to this alternate interior. And we'll put that in step 2. That's going to be angle SQT and angle RTQ. since those are alternate interior angles, we've got the alternate interior angles there. That gives us a second set of corresponding parts. At this point, we have two sets of corresponding angles congruent to each other. Third step, we'll go back to what we talked about before. We share side QT, so let's put it in. QT is congruent to itself by the reflexive property. And I forgot to mark that in our picture, so let's do that. QT is congruent to itself. We'll mark that right there. Now we've got three sets of corresponding parts that are congruent to each other, so we can say the triangles are congruent. Triangle SQT is going to be congruent to RTQ. We have to figure out which of our three-letter shortcuts we have here. Again, if it helps, you can cover up one of the triangles. We've got our two sets of angles congruent to each other. We've got the set of sides that's not in between those two angles. Which three-letter shortcut do we have here? What's that?
Is it ASA?
Close. You got the right letters, just not the right order. We got two sets of angles, the side that's not in between. No, it's AAS. Since the side is not between the two angles, it's going to be angle side. We have a non-included side here. And then, like we said, once the triangles are congruent, you can say the corresponding parts are congruent. That's going to make angle QTS congruent to angle TQI. All right, that's a lot of proofs. How many think they're starting to get the hang of these triangle proofs? Okay, the more of these you do, the easier they get. Now, the rest of those we're going to leave for you to work on. And hopefully you might be able to get those done here yet today. If you do get those finished, you can bring them back. We'll put them in the grade book today. You can also bring back that worksheet 4.4 to 4.5. We'll put that in the grade book. And then if you have time, you can also get started on that quiz review that you're going to do to get you ready for the quiz next time you come to class.